1. RP-Pico. The launch of the Raspberry Pi Pico and the RP2040 processor. It's based on injected new energy and interest into the world of microcontroller development boards. Until the Pico, Raspberry Pis were fully fledged single-board computers capable of running an operating system. The diminutive Pico is designed to interface with and control physical, real-world projects. It's a modern take on an established class of devices, including the venerable Arduino, and it's at a price point of less than $5. The specifications of the Pico are impressive. It has a fast dual-core processor, 2 MB of onboard flash memory, 26 I/O pins, 2 each of UART, SPI, and I2C controllers, 16 PMW channels, and an impressive 8 Piostate machines. In other words, it supports a huge variety of peripheral sensors and devices. Expert users can squeeze a lot of performance out of this device, but it's also ideally suited to beginners. Newbies can program their Pico in the easily accessible CircuitPython or MicroPython, while coding rock stars can still use C or C++. 2. Pi0. It doesn't mean that one is better than the other, you just need to have this difference in mind before making your choice. I explain everything you need to know in this article. If you need help getting started on Raspberry Pi, I have an entire course to guide you through your first steps. I'll help you use the perfect hardware, plug everything in and install your first system. You'll also do your first project with me, just to make sure you are ready for the next level. A computer versus controller. As explained in the introduction, the main difference to keep in mind is that the Raspberry Pi Zero is a single-board computer, while the Raspberry Pi Pico is a microcontroller. A single-board computer can basically do everything as traditional computer does, with limitations because it's not as powerful, and Raspberry Pi generally uses a Linux system. A microcontroller has generally one main task in an electronic circuit: get data from sensors, run a motor if a button is pressed, compute data sensors, and activate a LED or motor or transmit results using circuits, etc. That's why the Raspberry Pi Pico has little storage space available. It will only store a few lines of code on it. There is no SD card slot on it. We can run a full operating system on it. A Raspberry Pi Zero can absolutely run a full operating system like Raspberry Pi OS, even with a desktop environment. It won't be great for desktop usage, but it can easily be used to browse the web, write code on it, or host small servers. As soon as you need a specific app running on the Raspberry Pi, the Zero is your only option. You can't install traditional applications on a Pico, as there is no operating system. We can use the PO pins in Python like all the other Raspberry Pi models. The Raspberry Pi Zero has 40 PO pins available and comes with Python and many useful libraries pre-installed. It means that you can plug external accessories into these pins and interact with them via Python. That's where the Pico and the Zero share the most common points. We can do almost the same thing with a Pico. For PO projects, where the Raspberry Pi has a pretty specific and limited task to accomplish, you can often use any of them. 02W, you can basically do any Raspberry Pi project. In short, the Raspberry Pi Zero can run any Raspberry Pi project you'll find online. As long as you keep in mind the hardware limitations, everything is possible with this model. Raspberry Pi Pico projects examples. On the other hand, the Raspberry Pi Pico will be limited to smaller electronic projects. It's a cheap device that runs MicroPython and can be used to interact with sensors, motors or LEDs. For example, if you build a temperature monitor, you'll only need a Raspberry Pi Pico and a temperature sensor. You'll then write a few lines of code to get the temperature on a PO pin, and send it to a main server that will store the database and probably display the data for the end user. For some people, the Raspberry Pico might be easier to use, as there is no need to learn Linux to use it. You can plug it into your current computer to write the code, and that's it. You still need to know Python, but it's a smaller challenge for beginners. If budget is your priority, go for Raspberry Pi Pico. Easy availability is the first thing, go for Raspberry Pi Pico. Projects are simpler, Pi Pico wins again, but for complex projects and more connections Pi Zero takes the trophy. Want more memory? Raspberry Pi Zero wins the trophy. You prefer MicroPython over Raspberry Pi OS, then use Pi Pico. But want to explore new OS for future? Go for Raspberry Pi Zero. Having a size constraint, Pi Pico is smaller than Pi Zero. What is a microprocessor? As its name implies, it is a processing device that converts data into information based on some sets of instructions. It is a very compact electronic chip, due to which it is referred to as the microprocessor. In other words, a processing device implemented on a single chip is called a microprocessor. A microprocessor is the most crucial component of a computer or any other computing device, because it is entirely responsible for processing data based on instructions to produce information. In microcomputers, the microprocessor is used as the CPU. A typical microprocessor consists of two major parts, namely ALU and QUBIC. Intel 8085 or 8086 processing chips are the examples of microprocessors. Modern microprocessors consist of a small memory unit in addition to the ALU and QUBIC. Nowadays, microprocessors are being widely used in several applications such as desktop publishing, power plant control, multimeters, medical instruments, etc. What is a microcontroller? A microcontroller is an electronic system which consists of a processing element, a small memory, I/O ports, etc. on a single chip. Therefore, a microcontroller is a tiny resemblance of a microcomputer. It is a quite small and low-cost electronic device which is used in several electronic appliances as the main functioning device. In electronic systems such as washing machines, air conditioners, refrigerators, etc., microcontrollers are used to automate the operation of the device based on users' instructions. Hence, a microcontroller is the backbone of all embedded systems like microwave oven, washing machine, smart refrigerators, etc. Microprocessors find their application in light sensing and controlling devices, temperature sensing and controlling devices, fire detection and other safety devices, smart measuring instruments, etc.